Hey class, today's lesson is on solving a system of linear and quadratic equations. So let's jump right in. So first thing, we have three different types of solutions. Remember, the solution to a system is where the graphs intersect. So as you can see here, we have our quadratic function and our linear function, and they are intersecting at two places. So this has two solutions. And the solutions are going to be the coordinates of those intersecting points. So here we have a solution of 0, -3. And a solution of 4, 1, 2, 3, 4, 5. So here are our two solution points. In this graph, notice the linear and the quadratic function only intersect at one point. So we have one solution, and that intersection point is found at -2, 5. And finally, the third example, we have our quadratic and linear function not intersecting at all. And so we would have 0 solutions to this system, and there are none, so I'm just going to put NA. Okay, let's take a look at some more examples. This time we're going to have to graph the functions and then determine the solutions. So in example 4a, we have our quadratic in vertex form. So this is going to make it very easy to graph. So the first thing you should graph is your vertex. So our h value is -2, our k value is -6. So -2, -6 to get to our vertex. And then our a value is 1. So we would go to the left 1 and up 1. Go to the right 1 and up 1. Now we have 3 points. We could make our quadratic from here, but we're going to need more points. So to get the next points, remember you need to use the parent table for a quadratic. Remember, the parent table for a quadratic looks a little bit like this. So squaring -2, squaring -1, squaring 0, squaring 1, and squaring 2. And so since we don't have a vertical stretch or compression, we can just go ahead and apply this to our graph. So notice we went right 1, up 1, right 1, up 1. So to get to the next point, we would go right 2, up 4, right 2, up 4. And then the same the other direction, left 2, up 4. If you wanted some more points, it looks like we could fit a couple more points on here. Let's go to 3. 3 squared is 9. So we could go 3 to the right and up 9. And then left 3 and up 9. Okay, and now we can just draw a nice little sketch here of our quadratic function. Perfect. All right, let's go ahead and graph our linear function now. There it is. So as you recall, for a linear function, we start off by graphing the y-intercept, which is -2. And then we're going to graph our slope. Our slope is going to be rise over run, so we're going to rise 4, run 1. 1, 2, 3, 4, run 1. 1, 2, 3, 4, run 1. And going the other direction, 1, 2, 3, 4, left 1. So it looks like if you're very careful, you'll notice that it's going to intersect at only one point. That's going to be our y-intercept point right here. So we're going to have a solution of 0, -2. Okay, moving along. So on this one, notice our quadratic is in standard form. We could get 1 point out of this. We could get our y-intercept. We could plot that right away if we wanted to. 0, -3. But that doesn't really help us plot the whole thing. So we're going to need to change this to vertex form. So let's go ahead and do that. So we're going to start by getting another piece of paper, setting y equal to 0. Remember, to change to vertex form, we need to complete the square, so we're going to cancel out that constant. And since our a value is 1, we can go straight to our little formula for completing the square. So half of b squared is going to be 1. So remember, when you add 1 on one side, we're going to add 1 on the other side to keep it balanced. And since I completed the square here, I can convert that to x, half of b minus 1. Subtract the 4. So here we are. I'm going to go ahead and convert the 0 back to y, because that's what 0 represents. It represents y. Alright, now that I have vertex form, I can go ahead and graph the vertex, which is going to be 1, -4. And notice our a value is 1, so we can use the pattern for our parent. So 1, -4. Let me zoom in here a little bit, maybe, so you can see it a little better. And so we went left 1, up 1. So right 1, up 1. Following the pattern, 2, 4, 3, 9. And same thing on the other side. 1, 2, 1, 2. Go up that axis of symmetry. 1, 2, 3. 1, 2, 3. Remember, we can do that because it is symmetrical about the axis of symmetry. These points are equal distance from the axis of symmetry. Okay, graphing our line, our y-intercept is at -5. The slope is 0, so we're going to have a horizontal line because the slope is 0. Okay, so they do not intersect, so there is no solutions. Alright, let's move on. Next example. Oh boy, looks like we have another quadratic in standard form. Let's change it to vertex form real quick. So we're going to change the y to 0. Okay, we're going to move that constant to the other side. Well, our a value is a -1, which means we're going to have to factor it out. Okay, it's a little bit too close here. There we go. Then we're going to complete the square. So half of negative 2 squared is 1. 1 times negative 1 is negative 1. And if we subtract 1 on the right, we have to subtract 1 on the left. So I'm going to just do that. Doesn't matter, one or the other. Subtract 1 on both sides. Change forms. Since I completed this square, this is going to be x half of b. Then bring that 8 back over. And now we have vertex form. Vertex is 1, 8. And it's opening down. Okay, so let's graph it. So we have a vertex at 1, 8. Now, since our a value in this case is negative 1, we're going to go over 1, down 1. We're going to follow that parent pattern, but we're going to go down instead of up. Over 2, down 4. Go to that axis of symmetry and count the same number on the other side. Over 3, down 9. Go to that axis of symmetry. 1, 2, 3, 1, 2, 3. Looks like we could probably get another dot here, but we'll see. We'll see. Okay, now the linear y-intercept is 2. Slope is negative 2 over 1, so down 2, run 1. Down 2, run 1. Wonder if I got that point in the right spot. Let's see. 1, 2, 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yes, I did. And then rise 2, run 1. Rise 2, run 1. Rise 2, run 1. All right. Missed my dots. Can't undo that one. Oh well. You get the idea. So we know that it's going to cross somewhere in here and somewhere in here. Not at pretty points. Which means that either we would have to use a calculator, which we're not going to do, or we could solve this using substitution. So let's go ahead and do that. Let's go ahead and do substitution to solve this system. So basically, to do substitution to solve, we first have to make sure they're both in y equals, and we're going to set the two equations equal to each other. All right, and now we're going to solve this equation here for x. So we're going to make this side equal to 0. So we're going to cancel those out. How are we doing on time? Oh, we're running out of time. That's too bad. Just getting warmed up here. And then what we're going to do here is we're going to either solve this by factoring, or we could solve it by using quadratic formula. So what I want you to do right now for tomorrow is I want you to find the solutions to this quadratic. Hope you guys are having a good night. I'm going to be looking for those two solutions tomorrow.